Alright, so in chapter 3, section 2, I kind of alluded it to the last video. When you're looking at derivatives, you can do a first derivative test, which just is a way of finding your mins and maxes. In the book, they'll talk about your first derivative test. And basically, what it's saying is if something goes from decreasing to increasing, there is a minimum. If it's going from increasing to decreasing, there's a maximum. So it's kind of a common sense test, but we can find slopes by looking at the first derivative. So one I wanted to look at was number 2 from the homework. And so let's get a clean Desmos going. So find all relative extrema of the function. So we have x to the fourth minus 16x cubed. So let's graph that first so we get an idea what we're looking for. And so if we look at this one, I'm going to zoom in a little bit to see if I get anything better in there. It doesn't look like anything crazy happens, right? Not right there. I don't have any min or max. Let's go back home. Wonder if it, oh look, it eventually goes back up. So if I scroll back out and maybe let's go down a little bit, maybe like negative 200. Not enough. 2,000. Oh, one more zero. Way too far. We see that it does have this other minimum value way down here, right? That'd be hard to find graphically. We can see that it does, right? So when it's talking about, we see that there's no relative maximum. It goes up and up forever, but there is a relative minimum, right, on it, and it's right there. So at 12, we get this minimum value of negative 6912, exactly what they found here. But that takes some playing around with either your calculator or hopefully Desmos, because I think Desmos is a little easier to manipulate. So what we're going to do is find the derivative of this thing, set it equal to 0, and find those critical values where mins or maxes can occur. So you'll see that one in a supplement. Looking at number 5, find the maximum value of the absolute value of the second derivative. So we have to find the derivative twice, right? And we want to find the maximum value of that, the absolute value of that. This would kind of be neat to do visually on Desmos. So we get a 5 divided by x squared plus 1. So here's our original thing that we have. I'm going to let g of x be the derivative of f of x. Alright, so I see it. I'm going to let h of x be the second derivative of f of x. So I'll just be doing the, oh, so I got this purple thing now, right? So here is my second derivative equation. So this was my original function, this g is my first derivative, and h is now my second derivative, my derivative of my first derivative. But now if I wanted to do the absolute value of it, let's just do that. And so I get this purple line. It asks for the max, and I can clearly see that the maximum occurs at 10. So kind of a fun one to play around with Desmos on. Doing it algebraically, right, we would just want to see where the mins and the max were at and find out which value, the absolute value of the value, would be the highest. Because we would get these relative minimums here, right, or maximums, and I'd have this relative minimum here, but if I took the absolute value of all these things, which one would be the highest? It would be this negative 10. Again, they also did give me the values from 0 to 9. So mine occurs at 0 because at 9 it's very small y values. So take the derivative of this one twice, find these critical values where min and max occur, and whichever one has the highest absolute value. In this case, ours would be 10. Lastly, there's a word problem in number 6, and so word problems can be tricky. So this one is talking about an inverse proportional to the cube of the price. So it's really setting up the equation and being able to solve for that constant to help you figure this thing out. So because we have a quantity demanded for a product is inversely proportional to the cube of the price. So when the price is this, the quantity demanded is that. The initial cost is that, and the cost per unit is that. What price will yield a maximum profit? So we have to find these equations based off of what they've given us. So I'll set up the equations in the supplement to give you a guide to go through number 6.